terms you need to know. Energy is the ability to do work. There are two types of energy that I want you to know. There is potential energy and there is kinetic energy. What?
We know that we teach a class. It's
awesome.
Called Energy Lab.
Awesome. So you already know that kinetic energy is energy in motion.
Yeah, we use solar panels too.
Right. Okay. Waterfalls,
and we
water
talk
moving.
About that too.
Right. Well, then this will be totally easy for you. The movement of hydrogen ions will be used in the same way. You can use hydrogen ions to spin parts of proteins. Literally, the protein that makes ATP synthase.
ATPs.
Yeah. No, it's called, sorry, the protein that makes ATP, you're right, is called ATP synthase. And ATP synthase synthesizes ATP. Enzymes, the way they're named, tends to say what they're doing. So ATP synthase synthesizes ATP. And it literally spins like that. It is powered by hydrogen. What happens is the enzyme is here, and the hydrogen, it goes by, and as the hydrogen goes by, it makes it spin. Okay, does that make sense? Yeah. Moving hydrogen ions is what powers the ATP synthase and lets it make ATP. So, potential energy, again, it sounds like you know this. Potential energy is energy that could be used. The position of atoms in the chemical bond is a form of potential energy. Water stored behind a dam is potential energy. A gradient where you have more hydrogen ions on this side of the membrane than you do on this, that is potential energy. Good? All right, so that's not scary. Types of kinetic energy. You could have mechanical energy, like the pistons in your car moving up and down. You could have light. How is light a form of kinetic energy? Well, movement of photons, right? Photons are moving. You could have electrical energy. That's the movement of electrons, okay? You could have heat. That's the movement of all kinds of molecules. All of those are forms of kinetic energy. And since I made this big, I should have made it red too. You should notice heat is the movement, it causes the movement of particles, right? That's why heat, kinetic energy. That energy can be transferred to other particles. That's why if you take something that's cold and you touch it, it stops feeling cold. It's not that you habituate, it's that you transfer some of the heat from your body to that and warm it up. Good? Good? All right. So cells always need energy coming in to survive. So do ecosystems. Energy coming in, and you can use that energy to take, say, these monomers that come together and make polymers. It's never 100% efficient. You always have some waste heat. Does that make sense? There's always some waste. But here we have energy coming in, and the cell is happy. The cell is alive, even if it has some waste. No energy, no life. That's one of the reasons we say viruses are not alive. Viruses can survive without having energy input. So let's talk about anabolic and catabolic. We say something is anabolic. You guys know what Arnold Schwarzenegger looks like? Okay. Think of who else was a big anabolic side? Well, a lot of people. What are anabolic steroids? Steroids that help you add muscle, right? Anabolic, the A should remind you you're adding things, okay? So in anabolic reactions, you do things like you use energy to add things together. Here we have ADP, we're adding another phosphate, and what we've created is ATP. Good? That's anabolic. If you break it apart, that's catabolic. The C should remind you that you're cutting, you're taking one off, okay? ATP, which we make out of ADP and a phosphate, is the main source of energy for cells. There are other sources, but that's the main one. And the reason that it works, we have a negatively charged phosphate, a negatively charged phosphate, another negatively charged phosphate. You would agree, if we have this negative and this negative, it's just like magnets. They don't want another negative next to them. They don't want it there, and this one doesn't want to be there. It's like, oh, that's way too negative. I don't want to be there. The ATP synthase, as it spins around, what it actually does is it takes, it's like, oh, I don't want to be there. It spins around and it slams it in, literally slams it onto that molecule, makes it stick there. So that's how you make an ATP. So when we do this, the things that we're about to react in a chemical reaction are the reactants, and the things that we make are the products. The inputs are the reactants, the outputs are the products. That's not scary. Just basic terms you need to know. The activation energy is the amount of energy it takes to make a reaction go. to make it happen. If you think of a car, all right? Think of gasoline in a car. There's a lot of energy in gasoline, but you need a spark to get it to burn, right? You need something to start it. So you have spark plugs. So you have a source of energy to start the reaction. What catalysts do is lower the amount of energy it takes to make that reaction go. They don't take something that wouldn't happen ever and make it happen. They take something that would happen naturally on its own occasionally, and they make it happen every single time, all the time, non-stop, because they lower the amount of energy it takes for that to happen. Now, any catalyst does that. Enzymes are just a catalyst that you use in your cell that's made out of proteins. So metabolism is based on enzymes. And we got some words you have to know about enzymes. The enzyme is a protein catalyst. It is a protein that speeds up a chemical reaction. You're with me, right? The substrate is the thing the enzyme works on. So here's the substrate, and it settles down on the enzyme. The active site of the enzyme, that's the spot that does the work, it grabs onto the substrate. In this case, it stresses that carbohydrate until it breaks the bond, and then you have the sugar go free. So you need to know that an active site is the part that binds to the substrate. You need to know that the substrate is the molecule that the enzyme is working on. You need to know that the enzyme is a protein that speeds up a chemical reaction. I know those are not all in red, but I said you need to know. What do you think that means? It's on the test. You need to know it. If you add molecules together, it's anabolic. If you cut molecules apart, it's catabolic. Adding things together, you're synthesizing, and so that's why chemosynthesis, photosynthesis, in both of these you are making a bigger molecule. Cellular respiration, the stuff that happens in mitochondria, you are breaking bonds, you are cutting a big molecule apart. This is going to require energy. This is going to give off energy. Both of these use chains of enzymes. Both of these are multi-step reactions, and you need to have multiple enzymes. So multiple steps, you arrange them in what we call metabolic pathways. They're just chains of reactions where each enzyme does a little piece of the job, and what's the product of the first one becomes the reactant that's used by the second one. The enzyme 1, it makes A. But enzyme 2 takes A and makes B. And enzyme 3 takes B and makes C. You have to know this though. How do enzymes speed up a reaction? They lower the activation energy. Here we have a carbohydrate. Here we have simple sugar molecules, individual ones. We released the energy in that molecule when we broke all the bonds. So there was this much potential energy stored. We're now down to this much potential energy. That's a difference. But to make it happen, you have to put some energy in. This is your activation energy. Before you can break this apart, it takes a little energy to separate it all. What an enzyme does is it takes this activation energy and it lowers it so it takes less to make the reaction happen. That makes the reaction happen more often, makes it happen a lot more. So you could have starch break down into sugar. It would happen anyway. But if you put an enzyme in, it takes a lot less energy to happen, and it happens a lot more often than it would by itself. This is the exact enzyme that was in their drawing. You would agree, it grabs substrate A, it grabs substrate B, it brings them together at the right speed and the right orientation, and you get a product, right? Mm-hmm. And then it goes back and it does it again. The enzyme is not modified by this. It's like a little machine. That's okay. I've been bitten. Ow, he has teeth. Ow, ow.